Durable, versatile in texture, and made from natural materials, stucco has a long history of use on exterior walls. Even as it remains a popular choice in many places, it's also been the subject of recent issues and liabilities. These issues include cracking, moisture intrusion, and corrosion of the metal stucco base. Marginal lath embedment has been identified as a contributing factor to these problems. Specifically, the style of lath selected plays a significant role in enhancing embedment as well. Embedment describes lath's ability to be fully covered by wet plaster that cures to provide enduring cladding performance. The International Code Council's acceptance criteria for metal plaster base, AC 191, describes that the plaster base will provide a minimum of 1/4 inch embedment between the back plane of the metal plaster base and the back plane of the plaster, for a minimum of 1/2 of the area of the metal plaster base. In this case, the plaster base is the metal lath. To achieve this uniform 1/4 inch coverage, it is important to maintain a consistent tightness and furring of the lath against the base sheathing when attached. This video takes a close look at embedment across installations of 3 different styles of metal lath products: diamond mesh, woven wire, and welded wire. Regardless of the lath style, the greater the level of stucco embedment achieved during the application, the less likely the stucco system is to develop compromised stucco performance. The 2 common methods for application of the plaster to the lath is the mechanical pumping and spraying method and the mixing and hand troweling method. The pump and spray method is often seen on larger projects where volume is needed. This method can improve embedment due to the pressure of the spray. The hawk and trowel method is often seen on smaller projects. The method relies on the installer's skill in applying wet stucco into and through the openings. As for the use of slickers, a trowel-like tool that applies a larger quantity of plaster, this method is prohibited by ASTM C926. While contractors may prefer this tool, it tends to create cavities in wet stucco and may not fully embed the lath. As mentioned, issues stemming from improper embedment include cracking, as well as moisture intrusion that leads to corrosion. Cracking may occur when the scratch coat does not embed the lath properly, often because it is only applied on top of the lathing material, like icing on a cake. When the wet plaster that sits atop the lath in this fashion begins to cure, it does so more quickly than the lath that is properly embedded behind the lath, and this premature drying can contribute to cracking. The lack of stucco and lath connectivity can cause these materials to move independently of each other when subjected to seasonal weather changes, resulting in thermal deflection. These movement cycles may, after a period of time, widen small existing cracks and allow bulk water to enter the wall cladding. Cracking can be prevented by the lath's design, which enhances embedment by creating a monolithic cladding that moves compositely, rather than as 2 separate materials moving independently of one another. Thoroughly embedded lath in cured stucco acts compositely, like rebar does in concrete. Proper embedment is also critical to prevent moisture penetration. The better the lath embedment, the less likely the material is to oxidize and eventually rust under the stucco cladding. Incidental moisture that may enter the wall system can cause rusting and corrosion of the metal lath material if not allowed to dry out. Wind-driven rain and vapor drives moisture through the stucco to the weather barriers, resulting in condensation adjacent to the bare lath. If not dried out, oxidation begins, and the 3 mils of zinc coating protecting the expanded metal will eventually expose the carbon steel and cause lath corrosion and potential stucco failure. When the wall system combines proper embedment with adequate space for drainage and ventilation, the cladding is more likely to resist rust and corrosion. Now let's examine the 3 types of lath in terms of their propensity to achieve full embedment. As per ASTM C847, which specifies the physical properties of metal lath, diamond mesh lath is formed from sheet metal that has been slit and expanded to create keys or openings that are approximately 3/8 inch by 1/2 inch. Let's look at the application of stucco with diamond mesh. Contractors often mix their stucco stiff, using less water to get better surface contact. This stiff mud can increase the difficulty of pushing the stucco through the diamonds, reducing the ability to achieve embedment. With diamond mesh, it's critical for the installer to get both the ideal stiffness of the stucco mix and the proper pressure when troweling into and through the lath in order to properly penetrate the diamond openings. Expanded metal lath that is over-fastened to the substrate will restrict the passing of stucco through the diamond-shaped openings in the lath, negatively impacting embedment, especially at the edge joints and laps between sheets. ASTM C847 specifies the physical properties and manufacturing tolerances of diamond mesh lath, which is defined by weight. But the size of the openings is not standardized. This variability makes the pressure required to press a stucco mix through the openings different for each competitive product on the market. It is possible to achieve acceptable embedment with diamond mesh lath despite this variability, but the applicator must know the ideal stucco mix and application techniques to penetrate the diamond openings. Woven wire lath products are made of 17 and 20 gauge wire wound into a hexagon shape, with each adjoining shape woven together, as per ASTM C1032. The galvanization of woven wire is Class 1 per ASTM A641, which is equivalent to the G60 coating found on diamond mesh lath products. This style of lath comes in rolls instead of sheets and has an open design which provides for easier keying of the stucco material in the scratch coat. Here is an application of stucco with woven wire. While some manufacturers of woven wire make self-furring products, others do not. Without a self-furring product, the installer must create the proper distance from the wall using a furring nail or wad. With woven wire, inconsistencies in furring, as well as over or under fastening, can result in areas where full embedment is lost. Welded wire lath also comes in a roll with an open wire design similar to woven wire. Welded wire, shown here, rolls out with very little memory, allowing it to lay flat, while the tension that is stored in woven wire from the manufacturing process gives the rolls an inclination to wind back up on themselves. Diamond mesh lath is available in sheets, usually around 27 inches wide by 97 inches long, and formed by expanding sheet steel that has been slit and spread apart to form hundreds of keys per square yard. Due to its long-standing history as a building material, contractors are very familiar with lathing material in this format and using it effectively on a job site. Let's watch an application of stucco to welded wire. Due to the stiffness and uniformity of welded wire, it is perceived to be the easiest to properly embed. With welded wire, installers must make sure the scratch coat is not too wet and slumps off before it sets, or too dry and not fully packed around the wires. The uniformity of the furring found on welded wire lath provides an ideal plaster base for the wet plaster to be easily embedded into the wire reinforcement. It's important to note that there are regional preferences for the different types of metal lath. Diamond mesh has historically been the choice in the Southeast, Northeast, and Midwest. However, welded wire has seen rapid growth in this region due to its quality, consistency, and ease of use. In Texas and the Mountain States, diamond mesh and woven wire are more prevalent. But welded wire, the newest material type, is making steady inroads to this market as well. Finally, the Western United States and Desert Southwest have primarily used woven wire laths due to their relatively low level of moisture-related issues, allowing them to avoid the issues that stem from furring inconsistencies with woven wire products. Though, in the past several years, welded wire has seen a surge in popularity in this region due to the more consistent furring, improving embedment, and mitigating the non-moisture-related issues, such as the cracking that occurs when the lath and the stucco mixture are not monolithic. Proper embedment is critical to mitigating cracking and moisture intrusion. Ideal stucco embedment can be achieved by following these best practices. Make sure that the metal lath is uniformly fastened and evenly furred across the wall. Remember that while many of these products have built-in features for furring, some of these are more consistent and resistant to damage than others. Mix your stucco for your scratch coat in such a way that the mix can be forced through the openings in your chosen lath with sufficient trowel pressure or spray force. Keep in mind that self-furring lath products tend to help with maintaining consistency across the plane of the surface, and open wire designs tend to make proper embedment of stucco easier. The larger the size of the openings in the lath material, the easier it will be to force the mixture through it. However, if the stucco mix is too wet, these larger openings have a more difficult time holding up the mixture for the same reason. Finally, specify the exact type of metal lath and its associated ASTM references that will work best for your project and its surrounding environment. The ClarkDietrich Architectural Specialty Group provides complimentary specification reviews and assistance with this process. For a complimentary specification review, contact info@clarkdietrich.com. To learn more, download the white paper, The Importance of Lath Embedment in Portland-Cement Plaster, available at clarkdietrich.com.